Hello everyone. In this video we are going to discuss about Jfit parameters. Jfit parameters are the parameters which give electrical behavior of Jfit. So Jfit parameters describe the electrical behavior. Jfit parameters we discussed here are DC drain resistance, AC drain resistance, transconductance, amplification factor and input resistance. These are the JFET parameters we are going to explain in this session. First one is the DC drain resistance represented by R subscript DS. It is also called static or ohmic resistance of the channel. It is the ratio of drain to source voltage to the drain current. DC drain resistance can be represented in equation form as RDS equal to VDS by ID. That means the ratio of drain source voltage to drain current. It is also called static or ohmic resistance of this channel. This is the first parameter, DC drain resistance. Second one is AC drain resistance represented by small r subscript d. It is also called dynamic drain resistance. It is the AC resistance between drain and source terminal when the JFET is operating in the pinch-off or saturation region. It is the ratio of small change in drain to source voltage to the corresponding change in drain current. Here change in drain source voltage to the change in drain current because the signals are AC. That's why here we take the parameter. AC drain resistance are going to measure. That's why we take the change in voltage and change in current. Therefore, AC drain resistance RD equal to delta VDS by delta ID. So, AC drain resistance is also called dynamic drain resistance. Third one is transconductance represented by GM. It is also called forward transconductance or forward transmittance. It is the ratio of small change in drain current to the corresponding change in gate to source voltage for a constant drain to source voltage. Transconductance GM equal to delta ID by delta VGS. Fourth parameter is the amplification factor. It is the ratio of small change in drain to source voltage to the corresponding change in gate to source voltage for a constant drain current. Amplification factor is represented by a symbol mu. Mu equal to delta VDS by delta VGS. Mu can be written as the product of transconductance and AC drain resistance. That means mu equal to RD into GM. RD equal to, we explain RD equal to delta VDS by delta ID. And GM equal to, here GM equal to delta ID by delta VGS. Here we can cancel delta ID and delta ID. Then we get delta VDS by delta VGS. So, amplification factor mu equal to delta VDS by delta VGS. That means it can be defined as a ratio of small change in drain to source voltage to the current corresponding change in gate to source voltage for a constant drain current. Next one is input resistance R subscript I. Gate to source junction of a JFET is reverse biased for its operation. We know that for the normal operation of a JFET, the input junction must be reverse biased. Here we are giving input to the gate to source terminal. So gate to source junction of a JFET must be reverse biased for its operation. Since we are giving the reverse bias to the gate terminal, the input resistance of JFET is very high, in the order of several mega ohm. Input resistance RIE equal to VGS divided by IGSS, where VGS is the gate to source voltage, IGSS is the gate reverse current. It is the order of nanoampere, means IGSS is very small. Current during reverse biased condition is very small. Gate reverse current, IGSS is a gate reverse current. Gate current is represented by the IGSS. It is in the order of nanoampere. Nanoampere means 10 raised to minus 9, very small value. Next topic is comparison between BJT and FET. On comparing BJT and FET, we know some points about BJT and FET. FET is a unipolar device, means the current in the device is carried by either electrons or holes. Hence, we call the FET as a unipolar device. But BJT is a bipolar device. That means the current in the device is carried by both electrons and holes. That means both majority carriers and minority carriers. So, FET is a unipolar device while BJT is a bipolar device. Second comparison is FET is a voltage control device. On the explanation or the working of the FET, we see that the output current is controlled by the gate source voltage. So we can say that FET is a voltage control device. But in BJT, we see that the output current is controlled by the input current by using the equation IC equal to beta IB. So it is a current control device. So FET is a voltage control device and BJT is a current control device. And third comparison is the input resistance of an FET is very high because we are giving the reverse bias to input terminal. That's why the input resistance is very high. It is in the order of several mega ohm range. It is one of the advantage of FET in many applications. But in BJT, input resistance is very low compared to FET in the order of few kilo ohm. Fourth comparison is FET has negative temperature coefficient at a high current level. Negative temperature coefficient at a high current level means current decreases as the temperature increases. Negative temperature coefficient means current decreases as temperature increases. But in BJT, positive temperature coefficient at a high current level means current increases with increasing temperature. Here current is collector current. So current increases with the increase in temperature. In FET, this negative temperature coefficient prevent the FET from thermal breakdown. But in BJT, the positive temperature coefficient leads to thermal breakdown. Fifth comparison is higher switching speed and cutoff frequency. The higher switching speed and cutoff frequency of FET is mainly due to it does not suffer or it does not have minority carrier storage effects. That's why FET has higher switching speed and cutoff frequency. But BJT has lower switching speed and cutoff frequency because it suffers from minority carrier storage effects. Therefore, it has lower switching speed and cutoff frequency. Next comparison is FET is less noisy compared to BJT. But BJT is more noisy compared to FET. Seventh comparison is FET IC fabrication is simple and occupies less space on IC. If we use FET for IC fabrication, its fabrication process is simple. And for fabricating the FET, we need less space on IC. But BJT fabrication process difficult. Fabrication on IC is difficult and it occupies more space on IC. Next comparison is FET is immune to radiation. But BJT is more susceptible to radiation. And ninth comparison is FET has low gain bandwidth product. Gain bandwidth product means gain into bandwidth. is the gain bandwidth product. It has low gain bandwidth product, but BJT has high gain bandwidth product. Last comparison is FET requires special handling during installation. During installation of FET, special handling techniques are required, but BJT does not require any special handling during installation. These are the comparison among BJT and FET. So in this video, we discuss the JFET parameters. 5 JFET parameters are discussed here and then compare the BJT and FET. That's all in this video. Thank you.